Hello, my dear students. Today we are going to continue the organic chemistry. We are going to discuss the cyclic hydrocarbons and their types. We are going to discuss the aromatic hydrocarbon, the benzene compounds, and the nomenclature of substituted benzene. And we are going to discuss the preparation and the chemical properties of the benzene. And finally, we are going to discuss the detergent industry. So let us start. Benzene has molecular formula C6H6. The structural formula of benzene. In 1931, the German scientist Kickel discovered its hexagonal cyclic shape, which contains alternating single and double bonds. As shown on the screen, the single and double bond are alternated in different ways. Here, my dear student, we can make ring indicate that the 6 electrons of pi bonds are delocalized at certain carbon atoms. Now, we are going to discuss the preparation of benzene in the industry. From coal tar. During destructive distillation of coal, heating in absence of air, it decomposes into gases and liquids. The most important of these liquids is a heavy black substance known as coal tar. By fractional distillation of coal tar, we obtain benzene at 80 till 82 degrees Celsius. Now, my dear student, we are going to discuss the preparation of benzene from aliphatic petroleum derivative. From normal hexane. Normal hexane is passed at high temperature on surface of platinum as a catalyst. This method is called catalytic reforming method. As shown on the screen, the equation of preparation normal hexane by heat in presence of platinum as catalyst, it gives benzene and releases 4H2. The second point here is the polymerization or trimerization of acetylene or ethane. By passing ethane vapor in a red-hot nickel tube, as shown on the screen equation, 3 moles of C2H2 in red-hot nickel tube, it gives benzene C6H6. From phenol, the third way for preparation of benzene from phenol. By passing phenol vapor on surface of hot zinc powder, which reduces phenol to benzene. As the equation proceeds on the screen, phenol plus zinc by heat gives benzene and zinc oxide is produced, so it is reduction reaction. Now we are going to discuss the preparation of benzene in lab from dry distillation of sodium benzoate with soda lime. As the equation proceeds on screen, sodium benzoate with soda lime, which is mixture of caustic soda, which is sodium hydroxide, and calcium oxide, which is quicklime. The sodium benzoate react with caustic soda, sodium hydroxide, giving benzene, and sodium carbonate is produced. Now we are going to discuss the nomenclature of benzene derivatives. The name of monosubstituted benzene. It is derived from the name of the atom or the group which is attached to benzene ring, followed by the word benzene. As shown on the screen, this compound is named nitrobenzene, and this compound is called chlorobenzene. Now we have given reason in this point. When a group is introduced in the benzene ring, only one compound is formed. The reason for that, because the 6 carbon atoms are similar, so the entering atom or the group attacks any carbon atom. So exercise here, nomenclature of some organic compounds. As shown on the screen, 2 benzene ring joined by single bond, which is called diphenyl, has structure formula C6H5 bond C6H5. This molecule, my dear student, is named as alkane, and we deal with the benzene ring as substitution and call it radical called phenyl, and the carbon number 2 of the longest continuous chain, which contains 3 carbon atoms. So its name will be 2-phenyl propane. Now we are going to discuss the name of di-substituted benzene. So we are going to discuss first the types of directing groups. When the second group is introduced in the benzene ring, there are 3 possibilities. Replacing a hydrogen atom called ortho, meta, and para. As shown on the screen, if A is the first group entering the benzene ring, so it is the carbon number 1 attached to H. Then the positions 2 and 6 named ortho, and positions 3 and 5 named meta, and the position 4 named para. So when the compound contains A group and introducing B group on the benzene ring, second group, we can put it in ortho position as shown on the screen, or in meta position as shown on the screen, or para position shown in the screen. Here, my dear student, this reaction depends on the attached group A. Some groups are ortho and para directing groups. What that means, the entering second group will enter the ortho and para position. These groups are alkyl radicals as methyl benzene as shown on the screen, hydroxy benzene as we call phenol as shown on the screen, and halogen attached to benzene may be fluorine, chlorine, bromine, iodine, and amino groups which is NH2 group as shown on the screen. For example, halogenation of toluene which is methyl benzene. Here the methyl benzene, which IUPAC name of toluene, here when reacts with chlorine in the presence of iron, it gives 2 products, orthochlorotoluene and parachlorotoluene, and 2 mole of HCl are produced. My dear students, we can name it IUPAC name for these compounds 2-chlorotoluene and 4-chlorotoluene. Meta-directing groups. Now we are going to discuss the groups which meta-directing groups, the second group. Formyl group, which is CHO group in the benzene ring, and carbonyl group, which is CO group in the benzene ring, and carboxyl group, which is COOH group in the benzene ring, and nitro groups, which is NO2 group in the benzene ring. For example, halogenation of nitrobenzene. My dear student, we have nitrobenzene in the beginning and reacts with 1 mole of chlorine in the presence of iron. Here the nitro group is meta-directing group, so it gives meta-chloro-nitrobenzene. This is common name, but the IUPAC name, we're numbering only, we be names of molecule, so it will be 3-chloro-nitrobenzene, and 1 mole of HCl is produced. The name of tri-substituted benzene. If the benzene is tri-substituted, the carbon atoms in the ring take numbers, where each carbon atom attached to a group or atom takes the same number. And the nomenclature of this compound is arranged according to alphabetic letter. For example, This molecule, we have chlorine and nitro and bromine. We have to numbering the carbon atom of the ring here by putting the lowest sum of the branches in the benzene ring. So we can get here 4 bromo, 1 chloro, 2 nitrobenzene. Remember, my dear student, here the alphabetic order will be applied to name the compound. My dear student, notice that the nomenclature by the IUPAC system considers only the numbering of benzene ring. Now, my dear students, we are going to discuss the physical properties of benzene. It is transparent liquid immiscible with water. It has pleasant smell. Its boiling point is 80 degrees Celsius. It burns in air with a black smoky flame, as its molecule contain large number of carbon atoms. Now we are going to discuss the chemical properties of benzene. Benzene react by 2 kinds of chemical reactions, addition and substitution. My dear student, remember, alkanes react by addition or substitution. Yes, alkanes react by substitution only, while alkene and alkyne reacts by addition. But here, benzene may react by addition or substitution. We are going to discuss the addition reactions first. The hydrogenation reaction. Benzene reacts with hydrogen under pressure and temperature in the presence of catalyst to give hexahydrobenzene or cyclohexane. As the equation proceeds on the screen, C6H6 plus 3H2 in the presence of heat, pressure and catalyst, it gives cyclohexane, which is an alkane. So, my dear student, we obtain here cycloalkane compound from aromatic compound. The halogenation reaction. Benzene react with chlorine or bromine in the direct sunlight to form hexahalocyclohexane. Here, my dear student, benzene reacts with chlorine in the direct sunlight to form an insecticide hexachlorocyclohexane called gamexane. So, my dear student, benzene here reacts with chlorine in the direct sunlight, gives gamexane, which is an insecticide. So we can obtain insecticide from benzene. Now, my dear student, we are going to discuss the substitution reactions. The halogenation reaction. Benzene reacts with chlorine in the indirect sunlight in the presence of iron 3 chloride as catalyst to form chlorobenzene. Here, my dear student, benzene reacts with chlorine in the ultraviolet presence of catalyst iron 3 chloride. It gives chlorobenzene and 1 mole of HCl is produced. Now, my dear student, we are going to discuss the halogen derivatives of the aromatic compounds. The aryl halides are used as insecticides, as DDT, which is dichloro-diphenyl trichloroethane. As shown on the screen, this molecule has the structure formula shown on the screen: dichloro-diphenyl trichloroethane. Now we have good reason in this point. The DDT has poisonous effect. The reason for that, due to the presence of the group CHCl3, which dissolves in fatty tissues of the insect and kill it. Another gives reason in this point. DDT was called ugliest compound because of the environmental problems which appeared during its usage. Now we are going to discuss the second type of substitution reaction, which is alkylation reaction, that we call Friedel-Crafts reaction. Here benzene react with alkyl halide where the hydrogen atom of benzene ring is replaced by an alkyl group, forming alkyl benzene. And this reaction usually takes place in the presence of anhydrous aluminum chloride AlCl3 as catalyst. As the equation proceeds on the screen, the benzene reacts with methyl chloride in the presence of anhydrous aluminum chloride and heat. It gives methyl benzene or toluene C6H5CH3 plus 1 mole HCl. Now we are going to discuss nitration reaction, the third type of reaction, which is substitution reaction. The benzene reacts with the nitric acid in the presence of concentrated sulfuric acid where the hydrogen atom of the benzene ring is replaced by nitro group, NO2 group. As the screen shows, my dear student, we are going to put the nitric acid on the benzene in the presence of conch-sulfuric acid. And here, my dear student, we form nitrobenzene compound. Here, my dear student, this reaction is called nitration reaction. As the equation proceeds on the screen, benzene reacts with concentrated nitric acid in the presence of conch-sulfuric acid at 50 degrees Celsius. It gives nitrobenzene releasing water molecule. Now we have give reason in this point. The polynitric organic compounds are very explosive because their molecules contain their own fuel, which is carbon besides oxygen, which is the oxidizing agent, and so burn rapidly, and also due to the weakness of the bond between N and O to form two strong bonds between carbon and oxygen in carbon dioxide and N and N bonds in the nitrogen molecule. So a great amount of heat and gases are produced accompanied by explosion. Now, my dear student, TNT is 2,4,6-trinitrotoluene, is one of the explosive nitro compound which was produced by millions of tons through the Second World War and is still produced until now. This compound is prepared by reaction between toluene and a mixture of concentrated nitric and sulfuric acid by ratio 1:1. As the equation proceeds on the screen, toluene reacts with nitric acid in the presence of concentrated sulfuric acid with 50 degrees Celsius. It gives TNT, which I back name 2,4,6-trinitrotoluene as shown on the screen. Now the fourth type of substitution reaction of benzene is sulfonation reaction, which is the reaction with concentrated sulfuric acid. In this reaction, my dear student, the hydrogen atom of the benzene ring is replaced by sulfonic acid group, SO3H group. Here, the equation of the reaction, benzene reacts with concentrated sulfuric acid, which is warm, gives benzene sulfonic acid releasing 1 mole of water. Here, my dear student, we are going to discuss the detergent industries. It depends on the aromatic sulfonic acid compounds after the treatment with caustic soda to obtain the water-soluble sodium salts. As the equation proceeds, my dear student, alkyl benzene sulfonic acid reacts with sodium hydroxide, giving sodium salt of alkyl benzene sulfonic acid, which is named detergent, and water is produced. My dear student, the molecule of detergent is composed of two main parts. Tail, which is long carbon chain, which is called alkyl benzene radical, which is hydrophobic. And head, the second part, it is ionic group, which is sodium salt of sulfonic acid group, which is hydrophilic. So, my dear student, we are going to discuss how the detergent removes the spots and dirts. When the detergent is dissolved in water, their molecules arrange themselves. The hydrophobic tail, my dear student, of each molecule is directed toward dirts and textile and adhere with them, while the hydrophilic head is directed toward water, so the detergent surrounds dirts completely. So, with any mechanical rubbing, the textile and dirts are repelled with each other. My dear student, if you look at the molecule of the detergent, here the detergent contains two parts: the hydrocarbon chain, which is tail, and the ionic head. And so, when putting the detergent in water and the textile, we find that the tail of the detergent adhere to the textile and the dirt, while the head, which is the ionic head, directed toward the water. So, with any mechanical rubbing, here the ionic head repel with each other, and so the oil or the dirt will be removed from the textile as shown on the screen. So, my dear student, because of both of the dirt and textile are covered with the positive head of the molecule, so repel with each other. My dear student, we are going to discuss some questions now. Choose the correct answer. Phenol is reduced by zinc and produces what? Normal hexane, cyclohexane, zinc phenate, benzene. If you think about it, yes, the answer it will be benzene. Next point. The product of halogenation of nitrobenzene is what? Orthochlorobenzene or parachlorobenzene or orthonitrochlorobenzene or metachloronitrobenzene. If you think about the answer and you know that the nitro group is meta-directing group, so the product here will be metachloronitrobenzene. Next point. Catalytic reforming method of normal hexane produces what? Normal hexane, cyclohexane, zinc phenate, benzene. If you think about it, yes, the answer it will be benzene. Next point. Benzene may react by what? Is it substitution only, addition only, elimination, or addition and substitution? If you think about it, yes, it will be addition and substitution. Next point. Dry distillation of sodium benzoate with soda lime produces what? Normal hexane, cyclohexane, zinc phenate, benzene. If you think about it, my dear student, yes, it will be benzene. And we have give reason. Alkynes and alkenes are more active than alkanes because the presence of weak pi bond, which is easily broken, that in alkene 1 pi bond, while in acetylene 2 pi bonds. Ethane gas burns with a smoky flame in limited amount of air. The reason for that, because carbon doesn't completely burn it. We have give reason. Cyclopropane and cyclobutane are very active compounds compared with the open chain alkanes because the angles between the bonds in cyclopropane equal 60 degree and in cyclobutane equal 90 degree, which are less than 109 degree, which means this 109 found in open chain alkanes, so leading to orbitals, so form a strong sigma bonds. The DDT has poisonous effect. The reason for that, due to the presence of CH3 molecule, so a great amount of heat and gases are produced accompanied by explosion. My dear students, we have reached to the end of our program today. I hope you understood all the points that we discussed in the hydrocarbon, and in the next episode we are going to discuss the hydrocarbon derivative. So till we meet again, my best wishes for you.